Hey everyone, welcome to the fourth part in the series of videos where we go over how you can install Okteto on your own Kubernetes cluster to enable a fantastic development experience for your team. In this particular video, we're going to be tackling the second last pending task, which is configuring an external storage to store the images pushed to the Okteto registry. So for some context before we begin with implementation, whenever you build your application images during development, they get pushed to the Okteto registry. Now what this does is it ensures that whenever you redeploy your environment, you are able to use the same images without building them again. It also ensures that if someone on your team has developed a particular image, the other person, if nothing has changed, they are able to use the same image. Now in the version of the installation we have done so far, this feature would still work, right? Because right now these images are being stored on the container file system. So as long as your containers or pods don't restart or crash, it is working. But of course, since this is Kubernetes, things crash, pods restart. So what we want to do is configure an external file storage system so that instead of storing in the container file system, we store it in a location which is more permanent and which won't restart when a pod crashes or something happens. So let's get to that. Let's open up the docs and see what we have here. Okay, Okteto supports different storage drivers, and what we are going to do is we are going to use a cloud storage to save all our application images, and since we have been working with GCP so far, let's use that. There are two ways to do this. One is using workload identity, which basically allows your pods to communicate as service accounts, and the second way is by creating a bucket and creating a service account key. To use the workload identity, you need to have this feature enabled on your cluster when you create it. I did not enable this, so I'm going to go with the second method of creating a service account and adding the keys. So before we do that, we'll first need to create a bucket where we'll be storing these container images. So let's hit the create button, and I'll call this bucket Okteto self-hosted. That should be fine. Continue. I'm going to continue with the default settings here, and just wait for the bucket to create. Okay, that was fast. So now let's create a service account which will enable us to interact with the bucket we just created. We'll hit create service account, add a name. I'll just call it Arsh GCP Okteto install, and to description, let's just add something like to store dev images. We're going to click create and continue, and we are going to give it for the sake of this video, let's just give it permissions to read and write to all storage buckets. But if you're configuring this when rolling out to your team, you should limit access to only the bucket we just created. We are going to click continue. This is not needed, and our service account is now ready. Let's go to the service account and download our keys. We'll create a new key, JSON. That's perfect. We have our keys downloaded. Let's see what the documentation says now. Okay, so once we have the key, what we need to do is create a secret. So let's do that. I'm going to copy this and go to my terminal and paste this. The name of the credentials is different, so let's just see which one it is. I know it is the BB8 one, so I'll add that and create this secret. Awesome. Now that we have the secret created, we need to add the following configuration to our Helm values. So let's just copy this and go to the config.yaml we have been adding all our install configuration to, paste them, and we need to add the bucket name and the project ID. So the bucket name is our Okteto self-hosted. We'll just copy paste that, and the project ID is, we can get that from here, wastwatch something, and I'll go back to VS Code and paste it, and that should be it. Let's apply this configuration by running I don't think this is in the right directory, so let's just run it via terminal. helm upgrade Okteto. We have been running this command anytime we want to upgrade our configuration, so let's just do exactly that and see. Awesome, looks like it is done upgrading our installation. Let's head over to the UI and see. We can already see that the one step for installation is gone, but let's actually verify if things are working or not, and we can do that by opening an application and running Okteto build deploy and see if the images get pushed. So let me create a new namespace for that and test this out. Testing storage, not the most ideal name, but let's go with that for now, and I'll open up our sample movies application. So in the movies application, let us run Okteto deploy build in the testing storage namespace, and what this should do is it should go through the code and start building the application images, and it will push them to the storage we have configured in Google Cloud. So let's wait for this to happen and we'll check our bucket and see if we see something there or not. So it is now done building our application images, and it says that it has pushed these images. So let's go back to the Google Cloud Storage console and see if we see something in our bucket. Nice. So this validates, if you see, we can see a Docker folder here. So this validates that, it actually built and pushed those images to this bucket. And the next time, whenever you try to run a build or someone else on your team tries to run a build and those images have already been pushed, it will use those images. And the good part is that if your pods restart or something happens, these images still get saved on the cloud storage. With that out of the way, we only have one final step left in our Okteto self-hosted installation, and this will be configuring build-kit persistency, and I'll tell you what that is and how that helps in the next video. So have fun playing around with Okteto till then, and I'll see you in that one.